Sound is on. Yeah. Thank you very much. Thank you for having me. First time on this conference. To be honest, if I knew a little bit more about the conference and the simulators, I would probably change this presentation a bit. But I think this will be a practical approach to how we use simulations, and I think you will see that there are some common things in between simulations and a practical approach. My name is Haukeberg. I work at the Norwegian Coastal Administration, Norwegian Pilot Services. My background is from the Navy, so I had approximately 15 years in the Navy. 6 years as commanding officer, so given my operational background, I'm quite familiar with simulations and maritime simulators, of course. I hope to show you today that VR isn't just cool tech. It can be a smart way to teach, smart way to learn, to practice a skill or a task. Learning by practice is not something new. It's something we have had along for quite a bit, and the difference from then and now is the technological tools available to facilitate the learning. I hope to show you that VR simulators are a powerful tool for learning. Let me start off with a critical situation. January 2017, HMS Otra ran straight into a cliff wall in a narrow sound between Bergen and Florø. There was significant damage, but no serious injuries. Just to make it clear, this incident wasn't the reason I ended up working in NCA, but I started in NCA at that time. But I was scheduled to be the commanding officer on the bridge that night. That experience never became mine. This reminds us of something important. Collisions are far too costly to be our classrooms. That's why we need realistic and safe training environments where no lives or assets are at risk. VR simulators are well suited for this because they provide a level of immersion and realism beyond traditional simulators. In this accident, like in many, elements of failure in operational coordination plays a key role. Root causes to incidents are often organizational, but it's the people that determine whether a situation turns out positively or negatively. HMS Otra is not the reason why we introduced VR in pilot training, but it is an example of why we should train decision-making and collaboration in simulated high-risk environments. Well, as we have seen the changes to the program as well, I'm between you and lunch, and that's a challenging place to be and a tough act to compete against. But what does a minesweeper crashing into a cliff and our pilot VR simulators have to do with you here today? I hope to show you that VR simulators are very suitable for training and decision support, and they provide a level of immersion and realism beyond traditional simulators. Using simulators with higher realism and immersion will increase the use of simulators in general. It has to be as good as reality or better. Traditional simulators often rely on building databases manually. They create models of terrain, infrastructure, and waterways, one by one based on specific needs. This approach is accurate, but it's time-consuming and not very flexible. The VR simulator is different. It uses open data, public sources. That means the entire Norwegian coastline, fairway, buoys, harbors, topography is already in the system. This allows us to simulate the real world quickly, accurately, and up to date, creating a powerful digital twin of our coast. A practical example, if one of our nautical experts in NCA installs a new light somewhere along the coast, that light will automatically show up in our simulator the next day. The simulator And the technology has been embraced by our pilots. The pilots are 100% in line with the research. VR simulations are realistic and immersive. The bottom images shows a tugboat training session, one in VR and the other in a traditional simulator. Notice the difference in graphics, realism, and details. These qualities of the simulator is what inspired us when we developed an extensive training curriculum. The Norwegian pilot services has been built on hands-on knowledge transfer for over 300 years. We have always known the best way to learn is to do. And it's a little bit sad to think about, but many of you sitting here today may only remember approximately 5% of what we're talking about up at this stage. But studies indicate that we retain up to 75% of what we learn by doing, which is why our training philosophy is rooted in practical experience and simulator-based learning. The pandemic kick-started the use of VR. We could no longer send pilots away for training, so we had to find in-house solutions. We believed VR would be realistic, immersive, and facilitate deeper learning. And importantly, cost-efficient. Over the years, both the system and our training have confirmed that belief. And we have designed our courses to reflect the top of the learning pyramid, where action leads to understanding. So what have we actually done? We purchased 15 portable VR systems in the pandemic, distributed across the country for local training with the ability to connect and train together across locations. The experience was so positive that we decided to develop a proof of concept for a VR simulator in our offices in Ålesund. So we installed 12 stationary computers, which gives us 3 fully equipped virtual bridges. And our total investment in hardware is about 170,000 euros, with the running costs around 200,000 euros, and that's including development. And the development are driven by the real operational value we experience when training. Let's have a look at one example. See, Bridge 2 is in the office there, and you zoom in. On Bridge 2, it's manned with 3 pilots in VR with 1 instructor. And that setup is from one of our newest additions to the course curriculum, Bridge Resource Management, specialized for pilots. Instructors can be physically present in the room with the trainees, or they can join virtually and move freely around the bridge environment. We use the VR simulator as a facilitator for experience sharing and real discussions based on actual incidents or near misses. One example is the Mein Schiff 3 near miss case. One beautiful December evening in Kristiansand came seconds away from ending in a disaster, a possibly new Costa Concordia accident. Mein Schiff 3 had a well-trained crew, a confident captain, and a young navigator being given responsibility. But when the captain overruled the plan mid-operation and increased speed heading into Dybingen Channel, the safety margins disappeared one by one. There was no single big mistake, just a change of small decisions and a breakdown in coordination. Both engines had to be set full astern and thrusters hard to port. The vessel barely avoided the rocks. It happened so fast, 33 minutes from when I boarded to when we nearly hit land, said the pilot. We use this story because it reminds us of what we really need to train for: coordination, role clarity, and critical decision-making under pressure. In several of our courses, we train for coordination and decision-making in demanding maritime operations. During the pandemic, we prepared for complex cruise operations by simulating various scenarios in multiple ports. And last winter, we had a near miss with a cruise vessel caught in extremely unpredictable weather. We sat down with the captains and a cruise company and together we developed joint, agreed-upon procedures and weather limitations based on these simulations. We also used the simulator to test future infrastructure developments, such as this proposed bridge crossing over a fjord in Vestlandet. So that's a little sneak peek of what we have done. What does the future hold for us? We are implementing the ice navigation module in our simulator. We also have tabletop training currently ongoing today and more planned in the future. We want to run exercises that bring relevant actors together, and they can be hybrid. Some actors are inside the simulator in VR, running the scenario from the bridge or deck or crane. Others can observe and contribute in the same room through a shared tactical view. To summarize, the future will be more complex. We need to train more together beforehand. Technology won't alone solve it, but when we combine technology with operational experience, cross-unit collaboration, and an open culture of sharing, we can strengthen readiness across the entire system. The VR simulator provides a powerful platform for training for coordination, crisis response, decision-making in a safe, controlled environment. It also connects teams across geographical and organizational boundaries. I hope what I've shared today can inspire for new collaboration across agency, companies, and sectors, because we all know the future belongs to those who train together and learn together and share their experiences. Thank you.
Thank you, Kurt. If I understood you correctly, you said that you might have given a slightly different presentation if you were in possession of better understanding of what this was. I'm glad you didn't. Of course, I don't know what the other presentation would look like, but this was pretty interesting.
Okay.
And it's, one of the points you make is that visualization and training together and creating a realistic, immersive environment is really important. And I'm on the nerd side of things, I'm deep down into the code and the basics of modeling. But it would be awesome to have these visualization tools also for debugging when you set up a co-simulation, when you run simulations, and to really see what's going on.
Yeah. Okay. Can I comment on that? Because that's two of the things I just saw that I wanted to say. Because as soon as you start putting things visually, and you use open source and open data, and we use a lot of public data, as soon as you start visualizing it, you get all the errors. You see that this house is missing, this data set has incorrect specifications.
Wrong sign.
Yeah.
Wrong coordinate system.
Yeah. So it's a kind of a verification of your public data sets also. So that's one aspect I wanted to. I would have shown that a bit more if I knew more about your topics. And also the other topic I would address is that pilots are really, really specialized in what they do. So they can get a feel with what you normally use data for to see if this is correct. But they get a feel if is this the correct ship? Is it acting like it should or whatever? So that's an interesting aspect because we look at the quality of the data by using subject matter experts, and that's interesting when you meet these people who are, as you say, a little bit nerdy about the details, but then you compare it with subject matter experts. That's interesting.
Yeah. All right. Questions and comments? Yeah.
Thank you. Just a quick question before the lunch. So does your simulators also consider the interaction between the vessels in shallow and restricted water, due to the very long coastal line of Norway, and it's really difficult to control all these vessels around the way? Thank you.
Yes, it does, and it's not my simulator. It's a company in Ålesund simulator, just to be clear. It does, and this is actually a true story, but the Norwegian Training Center in Manila is changing their courses now because the interaction between the ships in this simulator is much better than the traditional maritime simulators they have. So I know there is a simplicity to the hydrodynamics and the interaction and the forces and that stuff, but I think the persons that have made the simulators had done some really good calculations. So it, for instance, if you have a vessel that is berthed in a dock and you pass it with the ship, you get the effect that you drag it off. That works in a simulator and it's realistic. So for instance, the keel pilots who work in the locks in Hamburg, they love the simulator and they're not going back to traditional simulators. So subject matter experts, they like the simulator.
Yeah, one more question, or maybe a reflection. When you have the VR, it gives you that immersion, fully immersion for the situation, but also you lose the haptic feedback from the mechanics, like buttons or the dials that you would use in the real bridge. And especially if you are using it for the emergency training, those mechanical reflexes are quite important for the personnel. So what is your reflection on that? Like, how do you think the VR is a good way to also attack that direction?
Yeah, I would approach that question from with two directions. One of them is we are using the goggles we use. You can also see your own hands. So, for instance, we use the maneuvering sticks. You can use them physically also, and they are interacted with the VR. So that's one solution to that issue. And the other approach is that we have had this discussion several times with the pilots. But it's also about determining what are you training for, because are you training for the practical operation, or are you training for the cognitive and the stress handling of the operation and that stuff. So I always say that you have to use the correct tool. Sometimes a lecture is the right way, sometimes a simulation is the right way, sometimes physical training on object is the right time. So use it for what you want to achieve with your training, so to say. So it can be both ways, I would say. Yeah.
Thank you.
Yeah, I think we are maybe heading for lunch.
Yeah, well, thank you once again, Kurt.
Thank you.
Also, small joke before we go to lunch, nerdy joke. Did you know that the fractal dimension of the Norwegian coastal is roughly 1.5? But anyway, what this means is that you literally have an infinite, never-ending job if you want to administer a coastline.